Okay, let's move to the question number 8. The equation of the curve is y is equal to 4e to the power of 1 minus 2x under root 3x minus 1. Find the exact coordinate of the stationary point of the curve. The stationary point can be calculated by using the derivative of the equation and equating it with 0, and by using this equation we can find the x coordinate, and this x coordinate can be plugged in the given curve equation to find the y coordinate. Okay, so first we have the y, which is equals to 4 exponential of 1 minus 2x under root 3x minus 1. So we have the two functions, so we can apply product rule, which is derivative of uv with respect to dx is equals to u derivative of v with respect to x plus v derivative of u with respect to x. So this is the quotient rule we will apply in this case. So y is equals to 4. Now this one is u, this one is v, so we can write it under 3x minus 1. So derivative of u is derivative of exponential of 1 minus 2x over with respect to x plus exponential of 1 minus 2x remains same, and derivative of under root 3x minus 1 with respect to dx. Sorry, this one is dy over dx. Dy over dx is equals to the 4 and under root 3x minus 1 remains same. Derivative of exponential term will remain same, which is exponential of 1 minus 2x, and the derivative of the power, which is derivative of 1 minus 2x with respect to dx, plus exponential of 1 minus 2x remains same. Now derivative of the under root is 1 over 2 under root 3x minus 1, and the derivative of the 3x minus 1 with respect to dx, bracket close. Further solving, we will have dy over dx is equals to 4, and in bracket we will have under root 3x minus 1. This one is exponential of 1 minus 2x, derivative of 1 minus 2x negative 2, plus exponential of 1 minus 2x over 2 under root 3x minus 1, and derivative of 3x minus 1 is 3. To find the stationary point, or to find the x coordinate of stationary point, dy over dx is equal to 0. So we can say that 4 times negative 2 under root 3x minus 1 times exponential of 1 minus 2x plus 3 over 2 exponential of 1 minus 2x over under root 3x minus 1 is equal to 0. When we multiply by 4, we will have negative 8 exponential of 3x minus 1 times exponential of 1 minus 2x plus 12 over 2 exponential of 1 minus 2x over under root 3x minus 1 equal to 0. This one is 6. Taking exponential term common, we will have exponential of 1 minus 2x, and in bracket we will have negative 8 exponential under root 3x minus 1 plus 6 over under root 3x minus 1. This one is equal to 0. We have the two factor, and we know that exponential of 1 minus 2x cannot be 0 for x is real. So we have another factor, which is negative 8 under root of 3x minus 1 plus 6 over under root of 3x minus 1 equal to 0. Taking LCM, we will have under root 3x minus 1 and negative 8 times 3x minus 1 plus 6 equal to 0. Further solving, we will have negative 24x plus 8 plus 6 equal to 0. So further solving, we will have 24x is equals to 14, and this one is equals to 12, and this one is equal to x. So we can say that x is equals to 7 over 12. So we have the x coordinate of the stationary point. Plugging this stationary point in the equation of curve to find the y coordinate. For y coordinate, plug x is equal to 7 over 12 in equation of curve. So equation of curve is y is equals to x 4 times exponential of 1 minus 2x under root 3x minus 1. So this one is equal to 4 exponential of 1 minus 2 times x means 7 over 12 under root 3 times 7 over 12 minus 1. So further solving, we will have y is equal to 4 exponential of 6 minus 7 over 6, and this one is equal to the 4. So under root 7 minus 4 over 4. Further solving, we will have y is equals to 4 exponential of negative 1 over 6 times under root 3 over under root 4, and this one is equals to 4 over 2 exponential of negative 1 over 6 under root 3. So we can say that y coordinate is equals to 2 under root 3 exponential of negative 1 over 6. So we have the y coordinate and we have the x coordinate. So the stationary point is x coordinate, which is 7 over 12, and y coordinate is 2 under root 3 exponential of negative 1 over 6. That was the required. Thank you very much for watching my videos.